How do geological processes affect fossil integrity? Imagine uncovering a piece of ancient history and wondering how it managed to survive millions of years. The answer lies in the powerful forces of geology that shape and preserve fossils over time. When an organism dies, it doesn't automatically become a fossil. The surrounding environment and geological activities play a big role in whether it turns into a preserved remnant or disappears altogether. Right after death, rapid burial is essential. If the remains are quickly covered by sediments like mud, sand, or volcanic ash, they are protected from scavengers and oxygen that cause decay. Sedimentary environments such as lakes, riverbeds, or ocean floors are especially good at trapping remains because sediments accumulate fast. On the other hand, if the organism is left exposed on a mountaintop or in a dry desert, it decays quickly and is unlikely to fossilize. Once buried, minerals in groundwater start to seep into the remains. This process is called mineralization or permineralization. Minerals like calcium carbonate or silica replace the organic tissues, turning bones or shells into stone. This process preserves fine details of the original structure, making fossils more informative for scientists. Sometimes, the original material dissolves, leaving an impression called a mold. When minerals fill this mold, it forms a cast, creating a replica of the original organism. Geological forces continue to influence fossils long after burial. Tectonic activity can deform or fracture fossils, sometimes turning them into jagged pieces. Erosion can expose fossils at the surface or wash them away entirely. Sediment compaction over millions of years can squeeze and distort the shape of fossils, sometimes causing chemical changes that break down organic parts. Volcanic eruptions deposit ash layers that quickly bury organisms, which helps preserve them and provides a way to date the fossils using the ash layers. All these processes determine how complete and intact a fossil remains. They also influence what kind of environmental clues the fossil can provide. For example, mineralization can preserve tiny details that tell us about the organism's biology, while deformation might obscure important features. For anthropologists studying human ancestors, understanding these geological influences helps piece together ancient habitats, behaviors, and timelines. Knowing how geological processes affect fossils guides scientists in choosing the best sites for excavation and helps them interpret the fossils they find. It also helps distinguish natural changes caused by Earth movements from damage caused by human activity. So, the next time you see a fossil, remember that its journey through Earth's geological forces is what makes it a window into the distant past.